Given a linear transformation T, what would it mean to multiply the transformation itself by a scalar to produce some new transformation? And just to be clear, we're not multiplying a vector by a scalar here. We're imagining what it might mean to multiply the transformation by a scalar. Mathematicians have defined this to mean a transformation that outputs the original transformation's output scaled by the factor. And since a linear transformation can be represented as a matrix, this implies that scaling a linear transformation is equivalent to multiplying its matrix by a scalar. In other words, scaling each element of the matrix by c. Okay, so if that's scaling a linear transformation, then what might we define the sum of two linear transformations to be? Again, we aren't summing two vectors, we're summing two transformations. In other words, we're summing two functions. This sounds like function composition, applying the first transformation, then applying the second transformation. But that's not what we're going to do here. For example, we want to assume that the two transformations being added have the same domain. And function composition would require the domain of the second function to be the codomain of the first function. Mathematicians have defined the sum of two linear transformations to be the transformation that outputs the sum of the vector having being transformed independently by both of the two transformations. Since a linear transformation can be represented by a matrix, the matrix for the sum of two linear transformations can be found by summing the matrices of the two transformations, where the sum of two matrices is their element-wise addition.